Mrs. Ward, and I'm going to go over the factoring or review worksheet. So when I have a polynomial and I'm trying to factor, the first thing I'm going to do is look for the greatest common factor. So in this case, 20, 28, 60, and 4, they have a common factor of 4. There is no variable that's common to all 4 terms, so I'm not going to factor out a variable. I'm going to be left with 5AH plus 7AF minus 15XH minus 21XF. That's me just taking out 4 from all those coefficients. Then I'm going to factor by grouping, so I'm going to look at the first 2 terms. Oopsie, crayon, not a good choice. I'm going to look at the first 2 terms, and I'm going to look at the second 2 terms. I'm going to try and factor out the greatest common factor from those. So here's the 4. Here I'm going to factor out an A. That's the only thing that has in common, so I'm going to do a bracket for the 4. And then factoring out an A, and I'm left with 5H plus 7F. Looking at the next 2, I'm going to copy down that negative sign. I can factor out a 3 from the 15 and 21, and they both have an X, so I'm going to factor out a negative 3X. When I do that, I'm left with a positive 5H, and then since I factor out this negative sign, that's going to change this sign to a positive, and there'll be 7F. Now I see that I have that 5H, 7F are the same, so I'm going to factor those 2 out, so I'm going to be left with 4 times the quantity of 5H plus 7F times the quantity of A minus 3X. Remember, it does not matter the order that you write those factors in. So now when I look at number 2, I have 84, 48, 14, and 8. So I can factor out a U from this, or 2 from those coefficients, and then every single one has a U. So I'm going to factor out a U. And then I'm going to be left with 42 UV minus 24U minus 7V cubed, U is factored out, plus 4V squared, the U is factored out. Now from the first 2 terms, and the second 2 terms, I'm going to factor out the greatest common factor from each of those. So when I do that, here's the 2U. I'm going to put a bracket. From the 42 and 24, I can factor out 6. Then I have a UV and a U, so I can factor out a U. I'm going to be left with 7V minus 4. And then from the, here, I'm going to factor out a negative sign. And then from the V, from 7 and 4, can't factor anything out. But from the V cubed to the V squared, I can factor out a V squared. And I'm going to be left with, factored out that negative sign, so this becomes a positive 7V. Factor out this negative sign, so that changes to a 4. Now these 2 are the same. So I'm going to factor those out. So I'm going to have 2U times 7V minus 4, and then 6U minus V squared. And that's it completely factored. Okay, the next one, I have a trinomial, which means I'm going to product sum it if I can. First, I'm going to look for a greatest common factor between 10, 63, and 18. And there are no greatest common factors. If you're not sure, you can do menu, menu, algebra, factor, and then I can only check 2 at a time. So let's say I check 10 and 63. So I do 10, comma, 63, and hit enter, and then, oh, I'm sorry, I did the wrong thing. Menu, number, greatest common divisor, and then you would do 10, comma, 63, and then hit enter, and the greatest sum divisor going to both is 1, which means you can't factor anything out. So I'm going to do product sum. I'm going to multiply these 2. My product is going to be 180. My sum is going to be the middle term, which is negative 63. I usually just go in order until I find it. And here I end up with 6 and 3 and 60, negative, negative. That would give me a positive 180 and negative 63. So I'm going to do 10x squared minus 3x minus 60x plus 18. It does not matter the order you write the negative 3x and negative 6, so you'll end up with the same answer. Your work will just look a little bit different. In the first two terms, I'm going to factor on x and make that 10x minus 3. Then to factor out the negative, I'm going to factor out 6, and that'll be 10x minus 3. So now that'll simplify to 10x minus 3, and then 8x minus 6. Either way, you're going to get the same answer, different work. The next one, number 4, is a binomial, which means I only have 2 terms. I'm going to factor out the greatest common factor between 10 and 4, which is 2. And then between the variables, I think I can factor out a b, I can factor out an a. I'm going to be left with 5a plus 2, and just 2 because I factored out the ba. There's nothing left I can do with that 5a plus 2. Remember, when it's a binomial, there's only 3 times that you can factor it. One is if it's the difference of 2 perfect squares. Then the other ones are the sum or difference of 2 perfect cubes. Okay, number 5, again, I'm trying to factor. I look here and I can factor out an r. So I'm left with 4m squared plus 7m minus 2. And then I'm going to product sum. My product is negative 8. My sum is 7. So I'm going to take a positive 8 and a negative 1. That gives me a sum of 7, a product of negative 8. Okay. So I am going to leave that r out in front. And then this is going to be 4m squared plus 8m minus m minus 2. So from the first 2, I can factor out a 4m and be left with m plus 2. And from here, I'm going to factor out a negative 1. And I'm going to go ahead and write that one, m plus 2. So there's the r. Then this is m plus 2. 4m minus 1. Double check your parentheses, make sure nothing else can be simplified. Okay, from 54 and 114 and 60, I'm looking for the greatest common factor. So I'm going to say menu number, and I'm going to say greatest common factor, and I'm going to do the 54 and 114. And I can only do 2 at a time. So I'm going to see the greatest common factor is 6 from those 2, and 6 will also go into 60, so that's what I'm going to factor out. So 9r squared plus 8r plus 10. So now my product is 90. My sum is 19, so I'm going to end up using 10 and 9. So 6. I'm probably going to write as 9r plus 10r. That would be easier. Doesn't matter. Again, does not matter or you do those in. So I'm going to have 6, 9r, r plus 1. Double check and make sure there's no common factors and there aren't summed up. Okay, the next one, 9, 30, and 25. Well, 9 and 30 have a common factor 3. 3 will not go into 25, so I do not have anything that I can factor out. This one is still product sum because this middle term, that exponent is half this. So I'm still going to product sum it, but I'm going to use squares instead of raise the first time. So my product between 9 and 225, my product is 225. My sum is negative 30. So if I sat here and went 1 and 225, 2 won't go in there, 3 won't go in there. I don't think. I'm checking because I don't think it does. No, it does not. 4 won't go in there. 5 will go in there, so it's going to be 5 and 45. That still doesn't work. 6 won't go in there. 7 won't go in there. 8 won't go in there, I don't think. Nope. 9 won't go in there. 10, 11, 12. Okay, so 15 is going to be 15, 15. Those are the last ones. Those are both going to have to be negative. So we have 9n to the 4th minus 15n squared minus 15n squared plus 25. So all I'm doing is taking that negative 30n squared and separating it as negative 15n squared and negative 15n squared. So the exponent should not mess you up. Here I can, between the 9 and the 15, I can factor out 3 between the ends of the 4th and n squared and squared. I'm left with 3n squared minus 5. Here I can factor out a negative 5. I'm left with 3n squared. Factor out the negatives, so this becomes a negative 5. So I'm left with 3n squared minus 5 times 3n squared minus 5. I can leave it like that, which would be fine, or if I recognize that they are the same binomial, I can write it as that binomial squared. Either one is fine. Next one, I have the difference of two perfect squares, because I can rewrite 25n to the 4th as 5n squared minus 2 squared. That's how those are both squared. So the fact of the difference of two perfect squares is 5n squared plus 2, 5n squared minus 2. Okay, the next one, I have 24x to the 3rd and 375. First thing I'm going to do is factor out the greatest common factor. That 3 will go into there. I don't like having this lead coefficient negative, so I'm going to factor out a negative 3. And I'm going to end up with 8x to the 3rd minus 125. Now, remember, this is binomial, so it has to be the sum or difference of two perfect cubes, because it's not squared, obviously. So I'm going to think of this as this 8x cubed is 2x raised to the 3rd power minus, and then the cubed root of 25 is 5, so 5 to the 3rd. Now the pattern for the difference of two perfect cubes is a minus b, and then a squared plus ab plus b squared. That's the formula. So in this case, my a is the 2x, my b is the 5, and then I'm going to do a squared, so I'm going to take 2x and square it, and that's going to be 4x squared times a times b, and this plus sign stays plus sign, and I multiply and get 10x. And don't think of this as a negative 5. This formula takes care of the negative sign. You don't even have to think about it. And then negative 5 squared, or 5 squared, would be 25. So that's taking care of this part, and then I just have to remember to do the negative 3. That was part of it, and that is my final answer. Okay, the next one, I have 108 and 500. So I know it's divisible by 2. So let's start with 2, and I get 54x to the 3rd plus 250. And I can still factor out 2 from that. So I'm going to get 20. So 2 times 2, which is 4. So 27x to the 3rd plus 125. If you didn't want to think of it that way, because it's a lot of thinking, you could have done menu, number, greatest common divisor, and I'm going to put those two in, which were 108 and 500. 108, comma 500, and that should tell me 4, and I could skip that one step, but I didn't think you could do that, so I'm going to say. All right, so this is a perfect square cube. So this is 3x to the 3rd plus 5 to the 3rd. So it's the same formula as this guy, except for the signs change. So if I have the cube plus the cube, it's going to be a plus b, a squared minus ab plus b squared. So this is my a, this is my b. Here's that 4 hanging out in front. And I'm going to have 3x plus 5, and then 3x squared. So that would be 3 squared is 9, x squared is x squared, minus, multiply those two, which is 15x plus 5 squared, which is 25. And that is my final answer. Don't forget this 4. That's one of the biggest mistakes. Solve each equation by completing the square. When I complete the square, I want the lead coefficient to be positive, so I'm going to bring this 10 over here. I'm going to have 10b squared minus 20b. I want anything that doesn't have a variable on the other side, so I'm going to subtract 37 at the same time. Whatever this coefficient is, that's what I'm factoring out. So I'm going to have b squared minus 2b. I'm going to leave a space to add a number, is equal to negative 37. When I complete the square, you take the square root of b. Here's that minus sign, because whatever that is. Then you look at that middle term and you cut it in half. Divide by 2. So 2 divided by 2 is 1. Notice it's b minus 1. It's not b squared. It's not 1b. It's b minus 1 squared. Because when I take b minus 1 and I square it, so if I take b minus 1 and I square it, it'd be b minus 1 times b minus 1, b squared. When I do the outer and the inner, outer, inner, I'm going to have minus 2b plus 1. So I have that b squared minus 2b. In order to make that work, I have to have a plus 1 there. So I have to have a plus 1 there. So remember, with an equation, if I add something to the one side, left side, I have to add the same thing to the right side. So I put a 1 here, but I really added 10 times 1. So I really added 10 to this side, so I'm going to have to add 10 to this side, which is negative 27. Divide both sides by that 10. So now b minus 1 squared is equal to negative 27 over 10. When I go to take the square root, I'm going to have b minus 1 is equal to plus or minus the square root of negative 27 over 10. Now, I know there's no real solutions, but we are in calculus, so we should be able to find the complex solutions, which means we should be finding the i's. So we have b minus 1. I'm going to take care of the negative by putting an I there and think of it as the square root of 27 over the square root of 10. If I could simplify anything between the 20 and 7 and 10, I would do that right now, but I can't, so I'm not going to. Now I need to simplify the square root of 27 and simplify the square root of 10. So 27, if I do this and I do menu, number, factor, and I factor 27, remember when I'm taking the square root, I'm looking for pairs of numbers. So 27 is 3 times 3 times 3, which means I can think of that as the square root of 9 times the square root of 3, and the square root of 9 is 3. However you need to do this to make this 3 times the square root of 3, do it. So I'm going to have plus or minus, and then this is going to be I plus or minus 3 square roots of 3 all over the square root of 10. Oh, I wrote that so wrong. Just I there. And I really want to put that I somewhere else. Just in a second. So now I'm going to rationalize square root of 10 times the square root of 10. This is still b minus 1 because I haven't taken care of that minus 1 yet. Is equal to plus or minus, and then we're going to write 3i, and we're just going to rearrange the order between that I and the 3. Square root of 3 times the square root of 10 is the square root of 30, and this is all over 10. Last step is to add the 1 to this side. So b is equal to 1 plus or minus 3i times the square root of 30 over 10. I can leave it like that, and that is perfectly acceptable. Or I can have a common denominator and think of this over 1. Then have a common denominator, you multiply 10 over 10. I could think of it as b is equal to 10 plus or minus 3i times the square root of 30 over 10. Either one of those answers is perfectly acceptable, but you do have to simplify, you do have to rationalize, and you do have to have that I. And the next one, the variables are separated. The 77 is on the other side by itself. I'm going to factor out 2. I'm going to leave a space for the missing number. Complete the square, so I'm going to take half of 6, which is 3. 3 squared is 9, so that's the number that I'm going to put here. I'm really adding 2 times 9, which means I'm adding 18, so I'm going to add 18 to this side, and now end up being negative 55. Divide both sides by 2. take the square root. I'm going to do I times the square root of 59 over the square root of 2. Then I'm going to rationalize while I'm here. 59 is a prime number. If I wasn't sure, I could check it. Menu number factor 59. It's only 59. 2, so I'm going to multiply, so I'm going to n plus 3 is equal to, whoopsie, plus or minus. Get that. And then I'm going to have I times the square root of 118 all over 2. Okay, so the last thing I'm going to do is subtract 3 from both sides. So I'm going to say n is equal to negative 3 plus or minus I times the square root of 118 over 2. And did I check 118? I did not, but I know there's no factors. But let's just double check. Factor is 118, making sure that there's not a perfect square and there's not a perfect square in there. I could leave it like this and be done, or I can rewrite this negative 3 with the denominator of 2, and I can n is equal to negative 6 plus or minus I times the square root of 118 all over 2. Either one of those answers is fine. Okay, doing the next one, I'm going to bring, they're all negative. Let's just multiply everything by negative 1. I don't know. And then 20 is equal to a squared plus 8a. I rearranged the order at the same time. Now I'm going to complete the square. My variables are one side, the constants on the other. And 20 is equal to, add some number here, a plus half of 8 is 4. 4 squared is 16. So I'm going to add 16 to this side. If I add 16 to the right side, I'm going to add 16 to the left side. And I'm going to write 36 here. Taking the square root of both sides, the square root of 36 is 6. So I'm going to have plus or minus 6 is equal to a plus 4. So I'm going to have 6 is equal to a plus 4. And I'm going to have negative 6 is equal to a plus 4. Remember, you're going to have two solutions. They're going to be two different numbers, like two completely different numbers sometimes. So this is minus 4, minus 4. So 2 is equal to a. And here I subtract 4. And I get negative 10 is equal to a. So a is equal to 2 or negative 10. Last one, I am going to bring the 3m squared here, take the minus 3 over there. So I'm going to have 3m squared plus 6m is equal to negative 93. This one is easier for me to divide everything by 3, so I'm just going to go ahead and do that because I can see that right now that they're all divisible by 3. So I'm going to do m squared plus 2m is equal to negative 31. Now I'm going to complete the square. I'm going to add some random number here. So this will be m plus half of 2 is 1. 1 squared is 1, so I'm going to add 1 to this side, which means I'm going to add 1 to this side. Negative 31 plus a positive 1 is a negative 30. Square root. So m plus 1 is equal to plus or minus the square root of negative 30. So m plus 1 is equal to plus or minus, there's that I. Checking 30. I know it's 5 times 6, but just to show you, 30, 5 times 6, 2 times 3 times 5. But either way, it's all single, so no perfect squares. It's going to stay the square root of 30. Subtract 1, I get m is equal to negative 1 plus or minus I times the square root of 30. And I believe that's it. All right, see you next time in class. Remember, on the calculator activity, you're saving the document. In class, we said to save it as calc, C-A-L-C, save as. On your calculator, you go to save a document, you do doc, file, and then save as. You're going to call it calc. We started that in class. You save it. You cannot do the last part of that. The last part of that directions say for you to send it in. You can't send it in until you're in class, so you're going to have to wait until you come to class, but it should be saved. All right, I will see you next time. Hope this helps.